Imagine this. You are floating 400 kilometers above Earth, hanging over a glowing blue horizon. Below you, entire continents drift silently beneath thin clouds. There is no wind, no sound, no air, and yet, when you come back inside the spacecraft, you smell something. Not faintly, not metaphorically, you smell space. Welcome back to Dr. Malcolm. If you enjoy slow, cinematic explorations of the universe, consider subscribing, and for the next few minutes, turn the lights down. Because tonight, we're going to answer one of the strangest real questions astronauts have ever been asked. What does outer space actually smell like? For decades, astronauts have returned from spacewalks, EVAs, with the same report. The moment they open the airlock and remove their helmets, a smell fills the cabin. It clings to their gloves, their suits, their tools. They all struggle to describe it, but they try anyway. NASA astronaut Don Pettit said space smells like, well, hot metal. Like a welding arc. Others described it as burnt steak. Several compared it to gunpowder after a rifle has just been fired. And Apollo astronauts, the first humans to step onto another world, were even more specific. After walking on the moon, they climbed back into the lunar module, removed their helmets, and immediately noticed a powerful odor. Buzz Aldrin called it spent gunpowder. Not dust, not rock, not soil, gunpowder. And here's what makes this eerie. Space is a vacuum. There is no air. Smell requires molecules traveling through atmosphere into your nose. So how can something that exists in a vacuum have a smell at all? The secret is this. You never actually smell space while you're in space. You smell it when space comes back with you. After a spacewalk, astronauts don't immediately remove their helmets outside. That would be fatal. They re-enter through the airlock, seal the hatch, and slowly refill the chamber with air. During that repressurization, something invisible happens. Their suit, which has been exposed directly to the raw environment of orbit, begins reacting with oxygen, and that's when the smell appears. To understand why, we have to talk about something called atomic oxygen. Up in low Earth orbit, the atmosphere isn't gone. It's just incredibly thin. But sunlight at that altitude is brutally powerful. Ultraviolet radiation from the sun tears oxygen molecules apart. Instead of O2, the oxygen you breathe, you get single, highly reactive oxygen atoms. Atomic oxygen is not gentle. It behaves less like a gas and more like a microscopic chemical weapon. As astronauts orbit Earth at 28,000 kilometers per hour, these oxygen atoms slam into their suits. Not float, not drift, impact. Every second, trillions of particles strike the suit's outer layers, oxidizing metals, degrading plastics, and chemically altering everything exposed to space. It's similar to rusting, except it happens instantly and violently. The surface of the suit becomes coated with reaction byproducts, oxidized metals, and energized compounds. But here's the key. In the vacuum of space, those reaction products just sit there. No air carries them away. They wait. Then the astronaut comes inside. The airlock repressurizes, oxygen floods in, and suddenly all those altered particles begin reacting again. What the astronauts smell is chemistry happening in real time. It's similar to the smell after fireworks, or after striking a match, or after firing a gun. Gunpowder, burnt metal, and welding arcs all produce oxidized particles and ionized gases, almost exactly what forms on a spacesuit in orbit. In other words, you're smelling matter that was chemically modified by raw solar radiation and high-energy particle impacts. You are smelling sunlight's fingerprints. Now let's talk about lunar dust and Martian soil. Both are, honestly, unlike anything we find here on Earth. Lunar dust, for example, is incredibly fine and sharp, formed by billions of years of micrometeorite impacts. It clings to everything, and when astronauts brought it inside, they reported a scent a bit like spent gunpowder or wet ashes. Martian soil, on the other hand, is rich in iron oxides. That's what gives Mars its reddish hue. When the first samples are eventually brought inside a habitat, scientists expect a smell that's metallic, maybe a bit tangy, and possibly even reminiscent of blood or rust. These are the chemical signatures of worlds beyond our own, telling their stories through scent and substance. The moon gave astronauts a similar but, slightly different experience. During the Apollo missions, lunar dust stuck to everything: boots, gloves, suits. Lunar dust is razor-sharp, microscopic rock created by billions of years of micrometeorite impacts. Without wind or water, the particles never erode smooth. They remain jagged like glass. When astronauts climbed back inside, the dust floated into the cabin, and then it reacted with oxygen. That reaction produced the famous spent gunpowder smell. Not because the moon has air, it doesn't, but because lunar material had been chemically activated by solar radiation for millions of years. Once exposed to oxygen inside the module, it underwent rapid oxidation. They were smelling freshly exposed extraterrestrial minerals, reacting with Earth-like air for the first time in geologic history. Mars would likely be different. Martian soil contains iron oxides, literal rust, and perchlorates, which are reactive salts. Scientists believe if humans enter a Mars habitat after a surface EVA, the smell may resemble hot dust, dry desert minerals, and possibly something like heated clay or a struck flint. More earthy than orbital space, but still sharp and metallic. And what about inside spacecraft long term? The International Space Station does not smell like space. It smells human. Closed environments create their own atmosphere. You have plastic insulation, electronics warming, recycled air, food packaging, cleaning agents, sweat, and trace amounts of body oils. Astronauts often describe the ISS as smelling like a mixture of machine shop, gym locker, and antiseptic hospital. Air filters constantly scrub contaminants, but nothing fully escapes human presence. Over months, a spacecraft develops a scent similar to a submarine lived in, warm, and faintly metallic, which creates a strange contrast. Outside the hatch, the scent of ionized atoms and solar radiation. Inside, humanity. Alright, so let's talk about something a bit unusual, how physics can actually become, sensory. You see, the universe isn't just something we study with equations and telescopes. Sometimes it's something we can almost feel or even smell. The invisible forces and particles out there, they leave their mark in ways you might not expect. It's a reminder that physics isn't just abstract, it's woven into the very fabric of our experiences, even in the tiniest, most surprising details. So, when people say space smells like gunpowder or burnt steak, they aren't imagining things. They're witnessing physics made sensory. You're not smelling air. You're smelling what happens when high-energy particles, ultraviolet light, and raw vacuum reshape matter. And then that matter meets oxygen again. Space itself has no odor, but it leaves a chemical signature on everything it touches. And when astronauts come home through the airlock, space comes home with them. One day, future explorers stepping onto Mars, Europa, or Titan will open their helmets inside new habitats and experience new alien scents for the first time in human history. Each world, its own chemistry. Each chemistry, its own smell. And perhaps one day humans will be able to recognize planets not just by telescope, but by memory, by scent. If you enjoyed this journey, subscribe to Dr. Malcolm and join me again as we explore the universe, not just how it looks, but how it feels. Because sometimes the strangest discoveries about space are the ones we can almost imagine breathing.